This video is a guide to calculating the kinetic store of an object, remembering that the kinetic store is related to an object's mass and its velocity, or how fast it's going. So let's take a look at the equation. We have that EK, which is energy kinetic, is equal to half mv squared, where m is the mass and v is the velocity, or the speed. Also remembering that energy is measured in joules, mass is measured in kilograms, and velocity is measured in meters per second. Now you may notice straight away that the velocity is a more important component than the mass. The velocity is squared, but we're going to look at just how much more important the velocity is than the mass in determining the kinetic store. So, how does the store change with mass and velocity? We'll start with mass. We'll write down our equation first, and we're going to choose some arbitrary values for the mass and the velocity. I'm just going to start with 1 kilogram and 1 meter per second. In this case, we get a kinetic store of half a joule, 0.5 joules. If I double the mass to 2 kilograms but keep the velocity the same, I will find that the energy in the kinetic store is 1 joule. In this case, as the mass has been doubled, the energy in the kinetic store has been doubled. If I multiply the mass by 3 times from the original, so we now have 3 kilograms, what we end up with is 1.5 joules. So by multiplying the mass by 3, I also multiply the kinetic store by 3. And finally, if I multiply the mass by 4, you should be able to guess now, the energy in the kinetic store is multiplied by 4. However, for the velocity, it's a different story. So for velocity, I'll write down our equation again, and I'll choose the same arbitrary values for our start point. We'll have a mass of 1 kilogram and a velocity of 1 meter per second. So we have half a joule inside the kinetic store. If we double the velocity to 2 meters per second, we do not double the energy in the kinetic store, but we quadruple it. Now, if we increase the velocity by 3 times from 1 to 3 meters per second, we end up multiplying the energy in the kinetic store by 9. And finally, if we do that by 4 times, so 4 times the velocity, we end up with 16 times the energy in the kinetic store. Now, the more mathsy people among you will notice the numbers go 4, 9, 16, and so you should be able to predict the next number, which is 25. This is because they are the square numbers. It is the velocity squared. So if I double the velocity, I quadruple the energy. If I triple the velocity, I multiply the energy by 9. If I multiply the velocity by 4, I multiply the energy by 16. If the velocity is 5 times bigger, it's 25 times the energy, and so on. So let's look at some actual calculations. A 700 kilogram Formula 1 racing car has a top speed of 100 meters per second. Calculate the kinetic energy of the car to 2 significant figures. So first of all, we write down our equation first. Then we replace the letters with the correct numbers. So we've got m is the mass, and so we pick the one with kilograms next to it. So it's 700 kilograms multiplied by the velocity. In this case, the velocity is 100 meters per second. Now remembering that that's 100 squared. So the first thing I'll do is I'll square that number to give us EK equals a half times 700 times by 10,000. Once I've done that, I'll multiply those numbers together, giving us 350,000, which works out as 3.5 million joules, or 3.5 megajoules. Next, a cheetah of mass 75 kilograms runs at a speed of 32 meters per second. Calculate the kinetic energy of the cheetah. So in this case, we write our equation again. We know that the cheetah has a mass of 75, so m is replaced by 75, and a speed of 32, so we replace v by 32. Again, I will square the numbers first. So we end up with EK equals a half times 75 times 1024. And finally, we get that the kinetic store of the cheetah is 38,400 joules. But since the question has only given two significant figures in each number, we've got 7, 5 and 3, 2, that's two significant figures each, then our answer should also be in two significant figures. So we will round down to 38,000 joules, or 38 kilojoules. Finally, a 160-gram cricket ball is hit at 44 meters per second. Calculate the kinetic energy of the cricket ball. In this case, we do not have kilograms, but we should have kilograms to calculate using mass. So we need to make a conversion. 160 grams, well, if 1,000 grams is 1 kilogram, then 160 grams is going to be 0.6 kilograms. We've divided the number by 1,000. Then, once we've done that, we can simply write our equation, plug in the numbers, squaring first, and then finally our answer is 154.88 joules. But since our question has only given us two significant figures, we need to round our answer, so we have that it is approximately equal to 150 joules.